Hi, this is Mr. Shumway. This video clip explains how to justify solution steps. So going from 2x plus 5 plus 3x equals 22 to 2x plus 3x plus 5 equals 22 can be justified by, well, all we did was move the two like terms close together, the 2x and the 3x, so that they're right close to each other. And so this is, when you're using addition, you can move them to different locations. The order of addition doesn't matter. We call that association. We can put them in a different order. So this is the additive, meaning that you're adding property. Well, let's write it this way. It's the associative property of addition. Meaning you can put them in, the order is not important. And we're talking about addition. That's the reason that the order is not important, is because we're adding. Going from 2x plus 4 equals 26 to 2x equals 30. Well, how did we get from one to the other? Let's see. If I wanted to get the opposite of add 4 is subtract 4. If I subtract 4 from 26, I should get 22. So we could say this one is not justified. Not justified. So someone made a mistake. So going from 2 parentheses 3x plus 4, or you might say 2 times the quantity 3x plus 4 to 6x plus 8 can be justified by, well, 2 times 3x is 6x, 2 times 4 is 8, so all we've done is just multiply that 2 times both terms inside the parentheses, and that is called the distributive property. Let's clean that up, sorry. So something that's done to both terms, we go ahead and do it to both terms. We distribute that multiplication through. Distribute. Going from 3 times the quantity 2x plus 5 equals 24 to 2x plus 5 equals 8, well, we could have divided both sides by 3. That's the opposite of multiply by 3. 3 divided by 3 is 1. 24 divided by 3 is 8. All we have left on the left, all that is remains on the left is 2x plus 5, and on the right we have 8. So what we did is we divided on both sides. So they're going to call this property the division equality. As long as I divide both sides by the same amount, they should still be equal. Okay, going from 2 times the quantity 3x plus 5 to 5x plus 7, how did we get there? Well, it looks like how they got there is they did 2 plus 3x. Well, this doesn't say 2 plus 3x. It doesn't say 2x plus 3x, so this one cannot be justified. They've made a mistake. Going from 3/4 of the quantity x plus 6 equals 2 to 3 times the quantity x plus 6 equals 8, how can we say it's okay to do that transition? Well, this 4 in the denominator means to divide by 4. The 3 in the numerator means to multiply by 3, so I'm going to multiply whatever's in the parentheses by 3 and then divide by 4. Well, the opposite of divide by 4 is multiply by 4. So if I multiply both sides by 4, 2 times 4 is 8. 4 divided by 4 is 1. 3 over 1 is just 3. So I basically canceled out the divide by 4 by multiplying by 4 on both sides. And since I've done it on both sides and they're still equal, then it's an equality. And what we did was multiply. Multiplication equality. Okay, so on the next one down, how did they get from 3/4 of the quantity x plus 3 equals 5 to 3 times x plus 3 equals 9? Well, if I were to multiply both sides by 4, 5 times 4 is 20, so they must have done 5 plus 4. So this one cannot be justified. They've made a mistake. So 3 plus 4x plus 5 equals 20. How did they get to 4 plus 3x plus 5x equals 20? Still have all the same numbers, but now the 3 has an x with it and the 5 has an x with it. So this one cannot be justified. That's not okay, even though you have all the same numbers. Now those numbers are associated with x that were not before, and so it's different. So going from 2x minus 6 equals 16 to 2x equals 22, well, how did they get there? Well, if I were to try to get it down to get the 2x all by itself, I would do the opposite of subtract 6, I would add 6. 16 plus 6 is 22. 2x plus 0 is 2x. So they did the same thing on both sides, so they will remain equal. Equality. So it's the additive. They added the same to both sides, so it would remain equal still.